spacing S is equal to 6 inches, and each fastener can support or resist, okay, 600 pound in single shear configuration. Okay, so if you look at here, so each fastener can withstand 600 pounds. So force can withstand is equal to 600 in pounds of force. The fastener can resist under single shear. Can you all remember what is the difference between single shear and double shear? Anyone, please? Can you remember? What do we mean by single shear and what do we mean by double shear?
When you have double, you technically have like two sectional areas, so you have to like multiply. I don't remember, multiply or divide by 2.
So the force can withstand is twice.
Yeah.
Okay.
That's
Okay.
double shear.
So I'll draw for you single shear. So let me recap. So I think you guys should have done this in 2P. Okay. So I know some of you have done 2P long time ago. Okay. So single shear configuration goes like this. So this is single shear. Okay, so if this is your bolt, right? So this is your bolt. So this is what we call a single shear configuration, where shear stress is equal to force divided by what? By area. Okay, so area over here is the cross-sectional area of the bolt. Okay, so this is single shear configuration. For double shear configuration, it just look like this. Okay, so now this is a double shear now. Slightly different. Okay, so you have your bolt now looks like this. Right, you have a bolt going in. So now over here, you have P. Over here, you have F and F. So this is what we call a double shear configuration. So the shear stress is equal to P divided by what? Twice the area, and area is cross-sectional area of the bolt, right? So why twice? Anyone can tell me why 2? Anyone? Okay.
So there are
So,
two areas.
yeah, well done. Okay.
Applied in that bolt.
Yeah, right. So one area is over here. Too thick. I should change that marker. So one area is over here. Eugene, wake up. One area is over here. The other area is over here. Okay, so these are the what? Areas. Okay. So whereas in a single shear configuration, over here is only one what? That's the only area. Right? Right. So now that's a very quick recap about single shear and double shear. Okay. So I'm going to copy. Any questions so far? Are you okay? So I believe you guys probably know that through 2P04, but as I said, some of you might have taken 2P04 long time ago. Okay. Right. So I'm going to copy the diagram if I could. Sorry. So copy the diagram. Bring over here. Right. Okay, so there are three possible failure modes over here. Okay, so if you look at the structure over here, there are three possible failure modes. Okay, we have three possible failure modes. Anyone? What's the first failure mode? Anyone, please. Number one.
The screws or nails break and shear.
Well done. So shear failure of the fastener. And the mode two, what's the other mode of failure? Anyone? Now, but before, so the shear failure of the fastener is based on what? Okay, based on the single shear force, right, of the fastener, or single shear force per fastener, which is equal to 600 pounds. And that's not all, and the spacing. Right, the spacing S is equal to what? 6 inches. That's why this spacing is critical. If you're going to load something or you're going to put a grand piano on your deck, okay, this spacing is going to be critical. Okay, you get it wrong, your wood will work, but your fastener will what? Will fail. Okay, I'm not asking you to put your piano on the deck, but this is what the design is meant for. Okay. Now failure mode number two. Anyone? Anyone want to guess what is the second failure mode? So first failure mode is the fastener. So if the fastener is good, what will fail next?
The wood and bending.
Yeah. Or the shear failure of the wooden structure. Okay. And you're right. It's also the normal. So it can be shear failure of the wooden structure. Okay. So shear failure. So this is controlled by the shear allowable by the wood, and we are given that the shear failure of the wood is 3 times 10 to the power 3 psi. And then finally, the third failure mode is normal stress failure of the wood structure due to bending moment. Okay, so we know for this case, the normal stress allowable is equal to 8 times 10 to the power 3 psi. Okay, so we are tasked. Okay, so for this question, we are tasked to determine. Okay, we are tasked. So we know there are 3 failure modes. We are tasked to determine right. We are tasked to determine the maximum value of P. Okay, we are tasked to determine the maximum value for P. And given, I don't want to do this in the question, you have to find the second moment of the area of this structure. Okay, I'm going to give that value. By now, all of you should be able to find the second moment of the structure. So if we were to have this structure or this diagram, the view over here. So this is my X, this is my Y, rotation about Z. Okay, so all these are 4 inches, 4 feet. We have to multiply by 12. So these are all 48 inches. Okay. Why we have to deal with inches is because our stresses are in what? Pounds per square what? Inch. Okay, we cannot deal in feet. If your stresses are in feet, pound per square feet, then you can live in feet. So you have to likewise multiply by 4, multiply by 12, 48 inches. The rest all are inches. And over here, this is our configuration. So there's a Y, Z, and rotation about X. Okay. So we're going to do mode 1 failure. So given that I is equal to 29,2902 inch to power of what? To power 4. Right. So we are going to look into failure mode. So number 1, the failure is due to the what do I call it? To the fastener. Okay. So we know that Q. So we're going to calculate Q first. Okay. So we know the how are we going to relate the force? Okay, how are we going to relate the force to the load that the fastener can withstand? So we know that Q, remember we had this formula before, we have Q is equal to what? All right, so we're going to use this formula, Q. All right, we're going to use that formula over there. All right, Q is equal to the force that the joint could withstand divided by the spacing of the screws or bolt. And if you look at the units, right? If you look at the unit for this expression, it's also in Newton per what? Per meter. So with this, you can relate the shear flow is also equal to, so for what we have written, is equal to Vy over Izz QZ. Okay. And there's no thickness, okay? You don't need to consider thickness. So these units over here is also equal to Newton per what? Per meter. Okay, are we clear? Right? So now, we know that Q, so we're going to calculate our Q first. So Q is equal to the force that the joint could take in a single shear. 600 divide by 6 inch the spacing. And if you look at this structure over here, question for you guys, if I have a shear force acting down here, that is my V in my Y direction, is this under single shear or double shear configuration? Anyone, please?